Welcome again to our today's lesson, and to proceed from where we had stopped, I had initially talked about a radioactive nuclide being able to get bombarded by a fast-moving high-energy particle to end up splitting and giving us two smaller nuclei. Nuclei is the plural of nucleus. So one radioactive nuclide or nucleus getting bombarded by a fast-moving high-energy particle, so that this nuclide or this atom in general ends up splitting to give us two smaller nuclei. The first nucleus, the second nucleus. Of course, the different nuclear composition or constitution in terms of the number of protons and the number of neutrons. To accompany these two nuclei, which are produced from this radioactive nuclide, we also have energy and radiations. This energy that gets produced here can get harnessed and put into very purposeful applications in our environment, such as this production of electricity, where the energy that gets produced here can be able to actually heat the water. The water forms steam. The steam can turn turbines, and this can be able to generate electricity in a hydroelectric power station. But now, let's come back and look at the radiations produced when a radioactive nuclide ends up splitting. So types of radiations produced in a radioactive emission, types of radiations. So the first type of a radiation that gets produced in this radioactive disintegration or spontaneous breakdown is called an alpha particle. It is symbolized as this, as an alpha particle. The second radiation is called a beta particle, symbolized as this, beta particle. And the third radiation that gets produced during this radioactivity is called a gamma radiation. And its symbol is that. So we have an alpha particle, a beta particle, and a gamma emission. Those are the three main types of radiations that are always able to get produced when a radioactive nuclide undergoes disintegration or spontaneous breakdown to form other nuclei with emission of energy. We shall be able to look at some of the features of each and every radiation getting produced in this case. And I'm going to begin with the alpha. For the first purpose of us understanding this, you can be able to actually understand that this alpha particle is abbreviated as that. That's the symbol of alpha particle. And this alpha particle is just a helium atom, a helium nuclei, a helium atom or an helium nuclei. And in this case, it is actually able to chemically appear as this. So you have capital H small e as the chemical formula of helium with a mass number of 4 and with an atomic number of 2. This helium carries a charge written as 2 positive. So the oxidation number is +2. We actually said in our last lesson that when you are capturing the charge on an atom of an element, begin with the number or the numeral, then the charge. But if that same charge is able to get captured in form of an oxidation state or number, begin with the charge, then capture the number later. So you can have an oxidation number of +2, but a charge of 2 positive. The oxidation number begins with the charge, but the charge begins with a number. That's the difference. So the charge is positive, and that means it's actually going to be 2 positive, but the oxidation number is +2. So helium particle or helium nuclei is an alpha particle. So if someone says a radioactive nuclide has emitted a helium particle, or a radioactive nuclide has emitted an alpha particle, just know a helium particle has been emitted. And in that process, it must have a mass number of 4 and atomic number 2 with a charge of 2 positive. What did I say? A radioactive nuclei or radioactive nuclide is represented using mass number and atomic number. So the mass number is 4 and the atomic number is 2. So the helium particle becomes an alpha particle that has a mass number of 4 and an atomic number of 2. You see, of all the three radiations, the alpha becomes the heaviest of all. Of all these three, the alpha, the beta, and the gamma, the alpha becomes the heaviest of the three. So alpha particle is a helium nuclide. It has a mass number of 4 and an atomic number of 2 with a charge of 2 positive. Of the three, it is the heaviest. It is the heaviest, having a mass number of 4. Okay, something else about this alpha particle. You can actually realize that the alpha particle is able to have a low penetrating power. It has a very low penetrating power. It has a very low penetrating power. A very low penetrating power. That is to mean if this is my alpha particle and I allow it to actually come from a radioactive substance such as lead, then you can actually end up having this alpha particle getting blocked by a thin sheet of paper. Thin sheet of paper. Just imagine a thin sheet of paper. This is a radioactive substance, a radioactive nuclide, being able to emit an alpha as a radiation or as a particle, which is a helium nuclide. When this particle is emitted from this radioactive substance, this particle gets blocked by a thin sheet of paper. So it has a very low penetrating power. So they do not pass through a sheet of paper. You see, so they have just a range of a few centimeters in air in terms of their penetration. They have a very low penetrating power. So they can get blocked by a thin sheet of paper. Can get blocked by a thin sheet of paper. So I have said in the first case that if you're talking about an alpha particle, it must be a helium nuclide. And a helium nuclide is positively charged, number one. It is the heaviest of the three radiations, having a mass number of 4 and an atomic number of 2. We've said it being very heavy, then that means it has a very low penetrating power, just being able to pass through a few centimeters in air and getting blocked by a thin sheet of paper. So you can be able to see its ability to get deflected in an electric field. For example, if I can be able to have this as my positively charged plate, and this becomes my negatively charged plate, where is this alpha particle going to get deflected? It is carrying a positive charge. So, like charges repel and unlike charges attract. So that means it is going to get deflected on the negative plate in our electric field. Look at that. An alpha particle being the heaviest with a mass number of 4 and being positively charged or having a charge of 2 positive and having a very low penetrating power, getting to that point of only having few centimeters getting covered and being able to get blocked by a thin sheet of paper, can end up getting deflected to the negative terminal, to the negative plate in an electric field. Why? Because it carries a positive charge. Carrying a positive charge makes it to get deflected to the negative plate in our electric field. So they are positively charged, so they get deflected to, or they get attracted to, the negative plate in that electric field. So they are not very light, they are very heavy. So they are very slight deflections. They have very slight deflections. Why? Because their heaviness will make them to move at a very slow speed and make them to slowly get deflected to a very smaller extent towards the negative plate in that electric field. And in terms of ionizing, we can be able to actually come here and say they have a greater ionizing power or ionizing effect. Of the three radiations, they have a very high ionizing power. They produce a large number of ions. For example, you have 4,2 He with 2 positive. And remember, they have a positive charge of 2. So just to imagine, you are actually having this as your ions. And these ions are getting produced by the helium, or the alpha particle, and they find their way into the air. You can try to imagine the ionizing effect they are going to have to these particles in the air. All these particles get ionized because of these positive ions getting produced by this helium particle. So they have a very high ionizing power. They produce a large number of ions. So that as they pass through gases, let's say these are gases, and due to their slow speed and high charge, this makes them to have a greater contact with the atoms for a longer time. I repeat, alpha is the heaviest with a mass number of 4 and an atomic number of 2. It's a helium particle with a charge of 2 positive. Having a charge of 2 positive makes it to get deflected to the negative plate in the electric field. It is actually able to get deflected to a smaller extent. Why? Because it is very heavy. It is the heaviest with a mass number of 4. To add on that, we are saying that it has a very greater ionizing power. Why? Because it carries a very big charge. It carries a greater charge. So, 1, it has a bigger charge. 2, it is very heavy. So as it moves in the air, what happens? It is heavy and having a greater charge, making it have a longer time in terms of its contact with target atoms in the air. It is very heavy, and with a bigger charge, it ends up moving very slowly. And as it moves very slowly, it has a longer time in as far as its contact with the target atoms in the air is concerned. So the longer time it has, in as far as its contact with the target atoms is concerned, it ends up having a higher ionizing power. It ends up having a higher ionizing power. So 3 properties to remember in as far as alpha particles are concerned. We've said an alpha particle is a helium nuclide that has the largest mass, which is 4 of the 3 radiations, and an atomic mass of 2. It has the highest charge. It has the highest charge, and it's positively charged. So when actually allowed to pass through an electric field, it gets deflected or attracted to the negative plate in the electric field. Being heavy, it has a smaller deflection or attraction. It only covers a shorter period in the air. It only covers a shorter distance, a few centimeters. Why? Its heaviness will make it to cover a shorter centimeters or a few centimeters in the air. And in that process, it gets blocked by a thin sheet of paper. And to move forward, we've said it having a bigger mass and being heavy for that matter, and having a slightly bigger charge, which is positive 2. It will end up moving slowly and covering few centimeters in the air. And in the process, it will end up having a longer time in contact with the target atoms of gases in the air. The longer time it has, in as far as its contact with the target atoms of the gases in the air is concerned, will make it have a high ionizing power. It ionizes those atoms. It makes those ions to become charged. It makes those atoms to become further charged. So its heaviness and its bigger charge and its longer time in contact with those atoms of those gases will make those atoms of those gases to become charged. So it has a high ionizing power when allowed to find its way into the air. And the second radiation is called a beta particle, abbreviated as that or symbolized as that. And this beta particle is able to get produced when a neutron is emitted from the nucleus. Look at that. So let's say this is our neutron, and this neutron is leaving the nucleus. Look at that. This is a neutron with a mass number of 1 and no atomic number. Look at that. And this neutron is splitting. On splitting, the neutron ends up forming a proton with a mass number of 1 and a proton number of 1. And further, it can also be able to now form what we call an electron with no mass number but now negatively charged. Look at that. So this is a neutron from the nucleus getting split to form a proton again within the nucleus, and also an electron is released. So a neutron with a mass number of 1 and no atomic number is getting split. On getting split, it forms a proton with a mass number of 1 and the proton number is able to get given as 1. It has no mass number, but it has a negative charge of -1, and it is actually able to get called an electron. For this case, you're going to realize that the mass numbers 1 plus 0 on the proton and the electron can add up to the mass number of the neutron. So 1 plus 0 is 1. Then the atomic numbers of the proton and the electron should also add up to the atomic number of the neutron. 1 plus -1, it gives you 0. So basically, this one becomes our beta particle. So in other words, a beta particle is an electron released when a neutron splits. A beta particle is an electron released when a neutron in the nucleus splits. So it is not an electron in the energy levels. It is a neutron in the nucleus splitting to form a proton and that beta particle or that electron. And that beta particle, which is an electron from the nucleus when a neutron splits, has a mass number of 0 and it is negatively charged. Look at that. It is now going to be the second lightest because we've talked about the helium that has a mass of 4 and of course an atomic number of 2 and is actually able to have a charge of 2 plus. So some of the differences to capture in these two is this. It is the heaviest with a mass number of 4. It is the second heaviest, of course, with a mass number of 0. It is positively charged. It is negatively charged. It is an alpha particle or a helium nuclide. It is an electron released from the nucleus when a neutron splits. Look at those differences. Something else to note is this. This one is able to become the second in terms of penetration. Look at that. The second in terms of the penetration. That is to tell you that this one is very, very, very heavy. It only covers a few centimeters in air. It is easily blocked by a thin sheet of paper. So it is the weakest in terms of penetration. This is the second particle to talk about in terms of penetration. It is able to pass through, let me say this is actually a radioactive substance like uranium. It is actually emitting a beta particle. Look at that. The beta particle can pass through a thin sheet of paper. Look at that. But can get blocked by an aluminium foil. See, so this is a thin sheet of paper. But this is an aluminium foil. An aluminium foil. So, a beta particle or an electron emitted from the nucleus when a neutron splits is better in terms of penetration. How? It can pass through a thin sheet of paper that gets to that point of blocking an alpha particle, but can now further be able to get blocked by an aluminium foil. Remember, an alpha particle gets blocked by this aluminium foil, and that means it can further as well be able to get blocked by this thin sheet of paper. So if a thin sheet of paper blocks this alpha particle and the beta particle penetrates the thin sheet of paper, then the beta particle is better in terms of penetration. So it actually passes through the thin sheet of paper that blocks the alpha particle but gets blocked by that aluminium foil. So it has a better penetrating power. A better penetrating power in terms of passing through the thin sheet of paper that blocks the alpha particle. So it has a higher penetrating power than the alpha particle. A higher penetrating power than the alpha particle. Higher penetrating power than the alpha particle. Higher penetrating power than the alpha particle. Now, in terms of deflection, let's come back to this deflection. You see, if you talk about a beta particle, look at that, a beta particle, which is an electron, you'll realize that the beta particle is actually an electron which is negatively charged. But I've talked about an alpha particle being a helium which is positively charged. So, this beta particle, which is an electron with a negative charge, gets deflected to the positive plate in the electric field. Why? It is carrying a negative charge. So the negative attracts the positive. or the negative is attracted to the positive. In other words, if you look at these two, you should actually realize that this one is lighter. It has no mass number, but this is very heavy with a mass number of 4. So it has a smaller extent of deflection. Let me just reduce this to this point. That makes sense. So it has a smaller extent of deflection because it is very heavy. It has a greater extent of deflection because it is very, very light. Look at that. A smaller extent of deflection because of its heaviness, a greater extent of deflection because of it being light. So get the difference in terms of where it gets deflected to the positive plate to the negative plate because of carrying different